Okay, so let's just start. And today we'll be starting with NumPy, and it is one of the most important framework that we will be learning in this internship. Okay, so do concentrate on it a lot, and I would recommend it you to practice it with a lot of precision because it will uh, it will help you in a long run. Okay, so let's get started. So what is NumPy? NumPy is basically a short form which is usually means numerical Python, sorry. It is basically used for lots of mathematical and statistical operations in the in in the field of machine learning and deep learning and so on. Uh, it is a library that uses for fast mathematicals and array operations, and it is also the foundation of various like ML libraries such as scikit-learn, TensorFlow, and Pandas. Pandas we will be learning in the upcoming lectures. It is basically used for exploration of data. Okay, so what does NumPy do? NumPy provides us the multi-dimensions arrays, linear algebraic operations, and random number generation. So what it means is like uh, in the field of deep in the machine learning, deep learning, or in the field of AI, there's a lots of mathematical operations in the backend. Okay, lots and lots of mathematical operations. Okay, so for that, we would require something called arrays. If you have, if you learned in your class in maths, like you would learn about some discrete mathematics. There are called discriminants and multiple type of matrices, right? Right. If you have learned about this, so basically arrays are matrices. Okay, it is a more than single dimension representation of numbers which contains a lot of data and which will uh, use in the further calculation in the while predicting the results of like machine learning model or calculating the effects of anything like in statistics and mathematical operations. It also provides the functionality of linear algebra operations, which means it's also provide you the functionality and freedom to operate on these matrices by your own. If you want to like multiply or use some kind of equation using matrices, you can easily do it in NumPy. Okay, and random number generation means it can generate random arrays on your wish. Yeah. Okay, so what is the difference between NumPy and list? Okay, why do we use we can also like use list in these operations. Basically it's a collection numbers, right? But why do we use NumPy arrays? Okay, so here as you can see in the scene, there's a difference. Why we use NumPy arrays? First of all, Python lists are heterogeneous, which means they can use various types. So various types of uh, inputs. Okay, like string, integer, float. But whereas NumPy arrays generally prefer to contains only a uh, single type of data, which is mostly numerical forms. Okay, and which since and regarding the speed, like NumPy arrays are much more faster as compared to Python lists because basically what is the NumPy arrays basic library that NumPy arrays you would use is basically written in C++. Okay, so it is C++ generally much more faster when uh, using operations or using numerical operations. Yeah, and memory. NumPy arrays usually, if you see the NumPy array can contains various amounts of numbers, but still it takes less memories as compared to Python list. Okay, and vectorized ops means operation. Okay, so vectorized operations means suppose you have to uh, contains calculation. Let's just say for example you want to multiply or add two matrices together. Okay, so what will Python do? It will like get confused in the operation, like which element should be multiplied with this or should I multiply with each and every element. So it will contain a lot of uh, numerical what contains a not lot of let's just say congestion in numbers, or you will always get the wrong output. Let's just move it with that, you will always get the wrong output. Whereas in NumPy arrays, if you try to, it is very easy to operate with such numbers at a very fast speed. So that's why NumPy arrays are mostly preferred for these calculations. Okay. So how do we create NumPy array? Okay. So as you can see on the screen, there is an example like how can we create a NumPy array. Here array you can see array is equal to np dot array, and we have given a list. Okay. So it will convert it the list into NumPy array format. Let me show you to the code. NP means NumPy. Here you can see also on the above there is an import statement. So let me go to the code. Okay. First of all, we will import NumPy as NP. NP generally it means that we have given it a name. Instead of writing NumPy again and again, we will just use NP. Okay. Uh, I think kernel is, yeah. So let's just take an example array. Here we will give a name array and store it give it to the array with the values of which contains a list 10, 20, 30. Okay. Now if I print type of array, okay. Basically I want to know what is the class of the array, in which class does array belong to. See, it is showing the NumPy ND array, which means it is a NumPy array. Okay. So as you can see, there's a various example. Like if I want to, as you can, yeah, in wait, yeah, in the slide, as you can see, there are very user also some built-in methods for NumPy. Like you can also create some array like this which means zeros. NP dot zeros is equal to 5. Okay, which means you will create a matrix of 5 zeros. Let me show you too. Okay, so here it is array. Let's just give it an something and zero. Zeros is equals to np dot zeros. Okay, and let's just say I am using the same value as example 5, and then we will get the value of zeros. See, it is an automatically created array which in which the 5 elements are 0. All the 5 elements are 0. Okay, as you can see on the screen. Similarly with ones, instead of being 0, it will have a value of 1. See, now instead of 1, I've used ones here instead of zeros. Then the array will create an array which will have the all the values of 1, and there will be 5 value in an array. So these are some built-in types. Like if you want to use, or if you don't want to create some kind of array again and again, then you can use this. Okay. And there's another called, yes sir, np dot arrange. I will call it arrange. Some calls arrange. Okay, which means is I want to create an array from 0 to 10, and the uh, like the step will be of 2, which means the array will contain like from 0 then 2, it will skip 1, from then 2 to 4 skip 3, basically even numbers. Let's just check it if I'm correct or not. Range array equal to np dot arrange. You can also see the description here. Okay, arrange 0 comma 10 comma 2. Let's just use range since we are on the no need to add anything. See, array of even numbers from 0 till 8. I mean, will till 10, but 10 it will stop before 10. Okay, it's basically uh, if you recall, like there was some range function when we were using loops. Then we also use a function called range, which will give us the range from one number to another. Okay, so it's basically like that. Instead of a, you can also say it like it's array range, or if you want. So basically, it's the same functionality with it. Okay. Now there's one more thing that uh, let me first do one thing. Instead of just five numbers or range 10, I will give it like let's just say 20. Okay. Yeah. So there's one more thing, like function called let me write in the comment. Mm, just okay. Range L dot shape. Okay. There's also a function called shape, which will return you the shape of the array. I mean, what is the dimension of the array? Okay. Let's see. Oh, tuple object is not. I think it shouldn't have parentheses. Okay. Yeah. See. So what is what is the range of shape of the array? Basically, are the it is the dimensions of the array. As you can see here, it is written in a shape of 10 comma, or then there is nothing, which means it is a one dimensional array. Okay, you have 10 elements from 0 till 18, if you count it will be count 10. So they are shape, which means there are 10 elements. Okay, or if I so basically it's a one dimensional array. If you have someone called 3 by 3 matrix, okay, then here if you use a function shape on that array, it will show you the shape of 3 by 3, 3 comma 3. Okay, and there is another function called, if I'm correctly, reshape. Yes, it will give you let me check. Yeah, let me do one thing. uh okay, let's check it if it's working like this. Not 10 comma 10. Since we have 10 elements, I will give it a shape of 5 comma 2. Let's see if I'm giving it the correct input. See here, earlier it was like arranged like this. Okay, now if I use the function reshape, what will it will do? It will uh, reshape the matrix. Okay, reshape the array or matrix. Okay, whatever you feel like calling it. So it will reshape the array. Okay, now you can see the entire structure of the array is changed. Okay, if I now uh, call the ask for the shape again, let's see what comes. 10 command. There's one more thing. If you found out from this, all the operations like this, uh, the NumPy creates a show you the copy of the original. Okay, it does not work on the original array. Okay, it will create a copy in the memory, and then all the operations will be done on that. Okay, if you want if you don't want it, you can just store it in a different variable. Okay, let's just say I will take a variable in. Okay, and now if I call the shape of a, see, 5 comma 2, 5 comma 2 means 5 rows and 2 columns, as you can see here. Yeah, it has 5 rows, 0, 4, 8, 12, 16, 1, 2, 3, 4, 5, and 2 columns where 0, 2. Okay, so moving on. Yeah, there's the next slide. So there are various array attributes. Earlier I was calling the functions. Basically, the correct term is attributes. Okay, so what are these attributes? As you can see on the screen, that there is some kind number of dimensions. Okay, array shape, the attribute we just saw here. Okay, and array dot size, total number of elements, and array dot data type. Data type, what is the data type of array? We will run this all these attributes in the code, and there are many attributes. When you start practicing NumPy, you will, by coding, by practicing, you will find there are many types of attributes. You can't even remember all the attributes in the array. Okay. So what are the attributes? Attributes help you understand and structure the type of your data. Okay. Like what kind of data you are working on it, or what is the structure of the data, so that in the you can easily manipulate or get the get some findings or inference from the data. Okay. Let's just see all these four attributes. What do they return in the code? Okay. What was the first one? I'm using this matrix here. Okay. So it is, I will be using the variable a. Okay. A dot, what was the first one? Endim. Okay. Let's just see. 2. What are the dimensions? 2, 5 and 2. Row and column. You can have made multiple dimensions, like 3 comma 3, you have a 3-dimensional array, 4-dimensional array, 5th-dimensional array. You can have multiple dimensional arrays. Okay. And it means number of dimensions. Here we have only two, the rows and columns. Okay. Now, what was another one? Array dot shape. Shape we have already seen here, since we have also kind of seen reshape. Okay. So I will be moving on to next. A dot size. Okay. What was the size? Like it returns the number of elements in the list, elements in the array. Sorry, it returns the number of elements in the array, which is equal to 10. Okay. A dot size. Size means number of elements in an array. And what was the last one? Sorry. Mm, yeah, data type. Let's see. A dot D type. I should hire. Let's just maximize it. Okay. A dot D type. Uh, int 64, which means uh, it is an integer type of array, because every value in an array you seeing is an integer. If I had the values like 2.3, 3.6, 7.8, these kind of values, if they are in array, then it will be float. Okay, instead of int 64, it will be float 64 or float 32. I don't remember. Then the data will be float. Basically, it's a like whenever you try to use a type function in a list in an array kind of variable, it returns you like it belongs to integer class or string class. So basically, it's an integer type of array. Okay. Or if you contain like floats, then it's floats type of array. Okay. Now, array operations. These are basically like how can you add an array. NumPy also provides you the functionality of like you can manipulate arrays, or you can just play with them. Like what will be the result of if you add two arrays, multiply, use a power operation, or any kind of. Okay. So operations are basically NumPy array provides you the operations, but these are element wise and vectorized. Okay. So what happens is element. So as you can see in that array operation, we have two arrays, 1, 2, 3, and second 4, 5, 6. If we provide the operation like addition, it will uh, add the elements of the list at that every position, like 1 plus 4, 5, 2 plus 5, 7, 3 plus 6, 9. Okay. And the second operation will be like in second operation given here is multiply. So it will multiply the elements of the array, not and it will not multiply like 1 into 4, 1 into 5, 1 into 6, then 2 into, not that. It will give you the element wise operation. Okay. And that what make a NumPy a fast library. That's why we use NumPy uh, as a statistical libraries, because of these types of operation speed. Okay. Speed and operations, all these facilities that we are getting it. Okay. uh, let's see. I have two arrays, right? Let's make one more. Okay. let's do one thing. I will to create two new arrays. Okay, air one np dot range. I will 1 comma 6. Okay, and array 2 will contain np dot dot range 1, not 1. Let's just say I will start from 6 till 11. Okay, let's see the arrays first. Oh, I think there is spelling mistake. Okay, so 5 and 5. Yeah, we have two arrays. One contains from integer 1 till 5, and another contains from 6 till 10. Okay, now we will see the array operations. Okay, let's say C is equals to, not C, let's just say S for some. Okay, array 1 plus array 2, and if we print S, see, it gives you the element wise or vectorized by vectorized uh, addition of the array. Okay, 1, so 6, 7, 2 plus 7, 9, 3 plus 8, 11, 4 plus 9, 13, 5 plus 10, 15. Okay, and if I try to like this time multiply, okay, and for multiply array 1, so array 2, and print m. Okay, see, it's still a element wise multiplication. Okay, and see, you it doing five computations simultaneously, but still it is like returning the results in a very extremely fast speed. Okay, so that's what NumPy differentiate NumPy from other kind of these array or list. Okay, uh it was like, yeah. So there's one more operation left, and which is we'll do power. Okay, this time we'll take only one array and make it a element wise square. Okay, see, now it every element has been squared. Okay, like earlier it was, yeah, here 1 2 3 4 5. Now you will see 1 4 9 16 25. It's the square of each and every element. Okay, so there like you can have multiple operations, like you can have subtraction, divide. You can like have multiple kinds of, you can like create some entire equation out of it. If like you can say y is equals to mx plus c, you can choose the value of m and c, or uh, use it use these matrices in some kind of quadratic equations. NumPy give you the extreme like freedom to use it anyhow. Okay, when you will try to practice NumPy, you should like go around and experiment around, like what is the limit, how far it can allow me. Okay, so next, statistical operations. This is the like this is where NumPy shines. Okay, you have an array. Now you want to compute some statistic measurements in this uh, on this array. Okay, so as you can see, NumPy give you the attributes called mean, median, and standard. It also give you mode. Okay, you can just practice it. All the statistical operations are present in NumPy because it is a library that is used a lot in statistics. Okay, so np.array, you have some numbers. You will compute a mean, median, and then standard deviation. Okay, so let's just go to code. We will see how it works. Uh, let's just create an array called and array 10 not 10, 5 comma 10 comma 15 comma 20 comma 25. Okay, let's see. Yeah, array has been created. Now I want to see array dot mean. Uh, let's see if I need to give a parenthesis or not. Okay, okay, I need to put it in some variable. Let's say mean now. Okay, let's see. Okay, I have to return something like that's why it was giving mean np dot mean. I'm sorry. I'm using np dot array. Okay, this is the right syntax. Sorry for the earlier. Uh, mean. Okay, now I will median p dot median array and st is equals to standard deviation np dot std, right? Mm, array. Okay, let's just say if they have mode or not. Let's see. Mode is equals to np dot mode. Okay, they have mod, but I don't think mod is a function we need, so we will leave it. Okay, so let's just see these three, and in the yeah, now I will print these mean comma np dot mean, not np dot mean, just mean. Since I've assigned it to variable, print what was the median? Yeah, median and median. Print standard deviation. These all the operations are statistical. If you have a little bit about the knowledge of the statistics, a little bit have knowledge of statistics, you will easily like know what these terms are. Okay, st. Okay, let's see. See, mean is 13. Okay, so if you average out these elements, the result you will get is 13. Okay, let's see. 5, 10, 15, 15, 30, 30, 40, 40, and 55. 55 divided by, huh? Like 15, 15, 30, 30 and 10, 40. 40 and 65. Yeah, 30. So you will divide 65 by 5, which is equal to 30. Okay. Median you have 10. Since uh you will, oh, I given like 10 two times. Okay, okay. I was calculating it wrong. Okay. So median you will get around is 13. If you arrange it in arranging order, you will get the middle or middle element, which is 10. Okay. And the standard deviation you will get by calculating the variance and square rooting it, okay? Which is like x minus mean n square divided by n root. I don't remember the exact formula. Okay, so these are the statistical operations. There are many types of statistical operation which NumPy provide. Okay, these are the basic ones. Okay, when you try to practice it, like you can search through net like any kind of uh num statistical operation like uh I keep forgetting their names, like advanced send advanced advanced statistical measurements. You can see on the net and try to calculate with NumPy. Okay, in while you are practicing. So next, reshaping and indexing. Okay, so as you can see, we have already created a reshape. How to reshape a array. Sorry, as you can see here, np.arrange 1 comma 10. It will create an array, and you will reshape it to 3 comma 3. We have already done that reshape, as you can see in the see here. We reshaped the array from it was earlier 10 comma nothing since it's a one dimensional, and then we create like reshaped it into 5 comma 2 this and see here. It wasn't. This was earlier array. Now when we reshaped it, uh, it is written. It is showing like this. Okay. So this is the reshaping of an array. Okay. Now there's also a call a thing called indexing. Basically, like when you try to access elements in the list, it's like equivalent to that now in array. Okay. Now if you want to array access element or access an entire row or access the entire column, so you can do this in array since it has many dimensions. Let's see here. Okay, what was in shape A? Okay, if I want to access, let's say I want to access first row. Okay, then I will give one and give column here. Okay, which means the first think of this column as an uh, separator between row and column. Okay, so on the left of the uh, column, you will give the row. Which row do you need? Okay, and in the left you will give the uh, column at the which element of column do you need. Okay, let's just say I'm accessing 1 comma 2 and 4 comma 6. Okay, what happens is first row second column. Where is that array? Let me just print it here. Okay, 4 comma 6 here. See what you are doing is you are asking like give me an row, first row till the second column. Okay, let me write it in a comment. Yes, I am asking for first row and second, not column, but basically, how should I put this? I'm asking for first index row. Okay, and second indexed column. Okay, let uh, let's experiment with it more. Okay, this time I'm asking for I think start from zero, row start from zero. Okay, and one. Let's see, array 0 comma 2. See, I'm asking for first row and first column. If I give 0 here, it will return an empty. Okay, shape 0 comma 2 determine. It will return an empty array because column starts from 1. Okay, see here. Huh. Let's check the example. I think I've 0 comma 2. Yeah, access element. Okay, okay. I think I've missed something here. Yeah, think I missed a comma. So instead of doing this, what I'm asking for actually is 0 comma 1. Using this, I mean I will get an element 2. Okay, here this element. Okay, earlier I was giving you the entire row and entire column. My mistake, I forgot about the comma. If I you instead of SC example, if I use this, okay, it will give an entire uh, let's just see the example array. Column means I will get the entire row with separation comma and 1. Okay, through which I will exit the entire column. Let me uh, explain it from the start. I think I made a mistake here. Okay, so if I try to go as given an example, I will access the row. Okay, entire row. of first column, my first index column. Okay, here I will written 2, that's why there is a second index column. Now I have 1. Okay, and now if I give it a 2, see, I will get the 2 rows till 2. Now if I give it a column and give it a value of 1, what happens? 2 comma 6. See, in now instead of getting a row, I am also getting a column. Okay, I want till 2. That means these are the index. Let's just say these are the you can see, you can also think of it as while indexing listed inside a list. Okay, now uh, think of it 0 comma 2 as single element and 4 comma 6 as single element. Okay, now what I'm asking for is colon 2 till I want the second element, yeah, which means 0 comma 1, which will be 0 comma 2 and 4 comma 6. And in these two elements, I'm asking for the uh, first element, which is indexed at 1. Okay, this one. Okay, yeah, if you have some, just a second. Okay, I think someone had raised them. Okay, yeah. So as you can see in the example, if I want to access element, it will give 0 comma 2 here, which means I'm asking for the element which is at the 0 row and second column. Okay, and array colon comma 1, it means I'm asking for the entire column. Okay, and with 1 I'm asking for the entire, which is position at the 1. Okay, let's see, array, sorry, a comma 1. See, here it gives me an full entire row. Okay, this row, second one. I think I'm okay. You understood by that this is a second row. Okay, if I use it here 0 instead of 1, it will give me first row since index starting from 0. Okay, now if I am asking like give me from position 2 to 4. Okay, so it has given me 8 comma 12, which basically means 0 1 2. I'm taking a second second till fourth index, which will be these two elements 8 comma 12, from column number 0, which means first column. Okay, column in after comma there is a column index, and after uh, before comma there will be row indexes. Okay, let's I think I've made a little bit mistake here. You can like ignore this comment. And here uh, it means I am asking for row index 2 from 2 till 4 in the first column. Okay, let me write a generalized version here. A means array. Okay, now whatever I write, let's just say I'm writing a comment. Okay, a index, I'm writing, let's just say m comma n. Okay, where m means row, row index. Okay, and n means column index. Okay, now you can also have like m colon uh any like m colon p, where you will ask from colon p means row index from m till p, and similarly n comma o and colon o, sorry, with n colon o. So basically what happening is think of it, uh, let me, if you create a list here, 1 comma 2 comma 3 comma 4 comma 5, how do you index the elements of the list? Okay, you will take it like give me element from 1 comma 4. Okay, from index 1 till index 4. Okay, and it will give you that. Now instead of the single this list, what you have is an array which contains a it contains an array which has more than one dimension. Here list you have only one dimension. Okay, it's just going in like 1 2 3 4 5 6. Now you have two dimensions, 0 2 4 6 8 10 12 14 16 18, like this. Okay, so now by comma being a separator, uh, you're accessing two lists at the simultaneous time. If you I, it's not actual factually correct, but I'm just trying to give an analogy that you'll be able to understand. Okay, because it you will get keep on confusing about that if you don't. I was also getting confused earlier. Okay, so remember this. Okay, this comment, like how to you can access the elements of an array using this statement, you can access it. Okay, now real world use case. Okay, what are the real world applications of an NumPy array? Okay, so NumPy arrays are used in image processing. Yeah, where each pixel a numerical value. When you like you working on images beyond the scope of this internship, but if you are interested in working in images, uh, there's a when you try to print an image, you will see that there's a large arrays of very small or very small 0.000 something numbers. These numbers are called pixels. Okay, and all these pixels are, when you try to operate on them, you will easily able to operate by using NumPy. Okay, because these arrays are best suited for NumPy, created in the first place using NumPy arrays. Okay, these are like foremost when you try to access images. Okay, then let's say if you have some kind of image. Okay, and you want to convert it into black and white, how will you do it? By manipulating the arrays that creates those pixels which create those image. Okay, so that's how powerful NumPy is. Basically all your operations, when you give an image to Gemini or ChatGPT or any other Gen AI model, uh, like edit this image in this mode, edit this image, convert this into black and white. All these operations in the back end at the very fundamental level are create are happening because of NumPy, because all the computers using NumPy to operate on these images. That's how you get an edited image. That's how this image is created. This image is nothing but a numerical representation of pixels, which are NumPy values. Okay. Also, they are used in financial analytics, machine learning, simulation models. Since machine learning is a very like entire foundation of AI, it's maths. Okay. And how can you calculate maths faster? That's how machine learning model, that's how all these big companies, tech giants, get an edge. Okay. So whoever calculate the faster will get an edge in the market. And these are the NumPy is the one of the most extremely fast library that is open source. Okay. That is used to calculate these. When you try to learn a machine learning model, well, try to run a machine learning model, it is basically calculating all these uh, training on all these values in the numerical format. Okay. And then predicting the output also in the numerical format. On all these calculations are happening in NumPy behind the scenes. So NumPy is that much important. Okay. As you can see in the third segment, behind every model, there's a NumPy array doing the math. All these small operations with very small numbers or very big numbers, the fast calculations happening on NumPy. So NumPy is an extremely important library. You should at least have a decent amount of knowledge in NumPy and hands-on practice. Okay. Okay. So we have reached the assignment. So your assignment for today, for this section or this lecture, is that we have to create a NumPy array and compute their mean, median, and standard deviation. Okay. And try with both one dimension and two-dimension arrays. And for memory refresher, uh, this is a 2D array. Okay. And where what is, yeah, this is an 1D array, one dimension. It has only has rows, no columns. Okay. It has both rows and columns. Okay. And one more task for you in this, try to take any user in dimensions of an array from the user and try to create from array from that. Okay. You can search net or do experimentation like how can we do it. It's fine. So instead of just creating a NumPy array like I created here, try to take the input dimensions from the user and then create an array and then operate using mean, median, and standard deviation. Okay. So that's it. Any doubts or anything you want me to repeat? Any doubts? If not, then we can conclude this lecture. Thank you.
Sir, like you said, NumPy is used for editing images, right?
Yeah, yeah,
Is there any other thing as such that is also used? Because आपने बोला जैसे कि ChatGPT and Gemini, all they all at the core they use NumPy. So
yeah.
is there anything else like such?
Actually, there's one more library called SciPy. Okay. बेसिक जो मोस्टली स्टैटिस्टिकल ऑपरेशंस होते हैं वो प्रेफर्ड सबसे ज़्यादा नमपाई होती है। एक साइपाई लाइब्रेरी और होती है, वो थोड़ी नमपाई से थोड़ी और ज़्यादा फास्ट होती है, पर नमपाई सफिशिएंट। ओके। और एनी अदर अगर कोई ऐसी लाइब्रेरी होगी तो वो उनकी प्रोप्राइटरी लाइब्रेरी होगी, वो ओपन सोर्स नहीं होगी। बट नमपाई इन itself is very sufficient library, so usually all the operations done are on numpy.
Okay, sir.
Okay, then thank you. Any other
Thank
doubts?
you, sir.
Any other doubts? No, I guess. Okay, then thank you.